the good sum which you have to keep in mind. Okay. Take it. Okay, let us see the difference in this sum and the previous sum. Outside is tan, I am not worried about it, I am just worried about inside part they are asking to prove. And what is important is they are saying evaluate, I think so. I think 2 tan inverse 1 upon 5 minus pi by 4. Now look at the inside part. Now 2 tan inverse x, I have no issue. I have the formula which I displayed. 2 tan inverse x you can write in terms of sine inverse, cos inverse, tan inverse. So you might be saying what we need to write it in. Now if you look at pi by 4 is tan inverse 1. So better this I can write in terms of tan inverse, because tan inverse x minus tan inverse 1, I can apply the formula and make it better, because inside will be tan inverse and tan of tan inverse will become compatible. So this is just nothing but a simplification part of sum. So very simple. Let me see how we go about it. So first case, what I am going to do is I will keep this tan as it is, because I cannot do anything unless until I simplify the inner part. Now 2 tan inverse x I will convert into tan inverse. Now what is the reason? Because 2 tan inverse x I will convert tan inverse, because pi by 4 is nothing but tan inverse 1. So this can be in terms of tan inverse, then tan inverse x minus tan inverse y, you can do it. So 2 tan inverse x, as per the formula, this will be tan inverse 2x upon 1 minus x square, right. So having done this, now let us see what happens. So this tan as it is, now look at this, what happens. This will be tan inverse as it is. So this will be 2 upon 5 upon 25 minus 1, that is 24 upon 25 minus tan inverse of 1. So I think I can eliminate whatever I could. 2 1s are, 2 12s are, 5 1s are, 5 5s are. So this will get, this 5 will go up over there. So this will generate into, this will become tan inverse 5 by 12 minus tan inverse 1. So I think it's very clear case of tan inverse x minus tan inverse y. So I can just write it down. So tan inverse, what is tan inverse x minus tan inverse y, children? It is tan inverse x minus y upon 1 plus xy. I hope this is very clear to you all what we do with it. Now you have to just work out the basic mathematics, nothing else in this. So let us see what happens now. Now tan of tan inverse, I'll just push it across this side. So this will be this, I'm writing it as it is. This is tan of tan inverse. Now 5 minus 12, understand what you're doing. 5 minus 12, 5 minus 12, if you're finding the LCM, 5 minus 12 will become minus 7. Then 12 plus 5, 17. And by the way, the 12 LCM gets eliminated. So tan inverse of tan inverse will becomes compatible. So this is nothing but minus 7 upon 17. So this is what the evaluation happens. This has come in IIT sum. Well, IIT, I don't know which year, but it was a nice question, simple one, because here some representation was done in terms of tan, and you can go ahead with this. So tan of tan inverse x, what is tan of tan inverse x? It is nothing but x, because this is my complete x, don't forget that this is my x. So tan of tan inverse x is nothing but x. There are other ways also to do this sum, but this is a better way because you are already acquainted with these formulas. So pause and note it down, children. Hi there. This question is the last part of this session. Tan inverse 1 by 4 plus tan inverse 2 by 9, and it is nothing but proving 1 upon 2 cos inverse 1 by 5. Okay. Now let us look at the LHS. Now this sum is slightly different, but not in terms of application of formula. So let us see how I do that. Tan inverse x plus tan inverse y, everybody knows what we do. We write tan inverse x plus y upon 1 minus xy. So this formula is already displayed on the board. You can have a look. So tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus xy. Now if I find the LCM and simplify this, what will happen? This will be nothing but 36 is the LCM in the numerator. So I think 9 plus 4 to the 8. I think 17 upon 36. This is 36 minus 2, 34 upon 36. Now if I eliminate this, 17 ones are, 17 twos are, and 36 gets cancelled. So finally the thing which is left out is tan inverse 1 by 2. Now, I just want you to make a note what we need to prove. This is something, that's why I said that this sum is a little bit special sum. I want to prove it is half of cos inverse 1 by 5, right? Okay. Now, this is the final result of this. Now, you see there is no cos at all in this. So, that's a big question here, okay. Now, what I am going to do is, if you see tan inverse I can convert into cos inverse just by drawing the right angle triangle, and the working can be looked upon and easily be attained in terms of cos. This 1 by 2 is a problem. So what I am going to do is, I am going to do something, I am just going to create this 1 by 2 artificially over here. So what will happen if I multiply by 2 and divide by 2? Why? Because that 1 by 2 will automatically generate over here. That's the reason I am dividing by 2 and multiplying by 2 and writing this tan inverse as it is. Now look at this, 2 tan inverse x. Now half is already there. That means 2 tan inverse x I can get into cos inverse. You can look at this next set of formulas. 2 tan inverse x in terms of cos inverse is nothing but, look at this now what I am doing, half of 2 tan inverse x. In terms of cos inverse x, what is the formula? It is cos inverse 1 minus x square upon 1 plus x square. So what happens finally? This will be half cos inverse 3 by 4 upon 5 by 4. So basically they are not asking us to prove, I think, look at the question, oh it is 3 by 5, sorry, it is 3 by 5. So finally what happens now in this case? Look at this pattern, this 4 get cancelled, so half cos inverse 3 by 5, so which is equal to RHS. So I hope you got this point clear. So just overlooking there, it is 3 by 5 and not 1 by 5. So what is the point here is this adjustment, because once you get tan inverse, you do right angle triangle, you get only cos inverse, but you will not get this half. So I got it by artificially creating that half. So some sums, exclusive sums are like this, okay. So I hope you understood how to apply. If you see across the 7-8 sums which you did in this session, was we applied tan inverse x plus tan inverse y, sin inverse x plus sin inverse y, and 2 tan inverse x I got converted into sin inverse, cos inverse, tan inverse, and applied depending upon what they are asking us in the question. Actually, this is the first category of sum that is based on proving part, and there is no level beyond this. The next category in the next session which you are going to see is solving of inverse trigonometric functions. So how I do that, we will see in the next session. Till then, pause and note it down, children. Okay, look at this question here. It is given tan inverse x plus 1 plus tan inverse x minus 1 is equal to tan inverse 8 by 31. Okay. So children, what is important in this case? Try to understand. So tan inverse x plus tan inverse y I can apply for the formula which I displayed it on the board. So let us see one point I want to share with you. There is a thing solve. What do you exactly mean by solving? You mean solving means finding the value of x in this inverse ratios. So it is clear cut tan inverse x plus 1 plus tan inverse x minus 1 is equal to tan inverse. The best way to keep in mind is whatever the right hand side ratio is there, you convert the left hand side into the same ratio. If there is tan inverse, convert this into tan inverse. If it is sin inverse, convert into sin inverse. And then you can equate the integral part. So you get the value of x directly. So let us begin with this. So this tan inverse x plus 1, tan inverse x minus 1 is equal to tan inverse 8 by 31. So I can apply the formula tan inverse x plus tan inverse y. So this will be tan inverse, try to understand what I am doing. It is x plus 1, x plus y. So tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus xy, that is x square minus 1, is equal to tan inverse 8 by 31. So try to understand this, what I did. Look at this, I am putting a bracket so that there is no mixing up. Solving, both sides I am converting into tan inverse. Of course, here it is tan inverse, so I have no issue. So tan inverse x plus tan inverse y, I am applying the formula. Tan inverse x, for me x is x plus 1 and y is x minus y. So tan inverse x plus y upon 1 minus xy. So xy is x plus 1 into x minus 1 is x square minus 1 is equal to tan inverse 8 by 31. So let us see what happens if I just simplify this out carefully. Remember, this 1 will get eliminated in the numerator. It will be tan inverse, this will be 2x upon, try to understand what will happen. This 1 minus x square, minus of minus become plus, so it will become 2 minus x square is equal to tan inverse 8 by 31. That's what exactly in the beginning I told you. Both are converted into tan inverse, right? So that's the reason what happens is you can equate the integral part of it and find the value of x. So this will be 2x upon 2 minus x square is equal to 8 upon 31. You have to just simplify this now. So what will happen now? You can say, you can just, if you want, you can simplify this part here. 2 1s are 2 4s are, because 2 if you cross multiply it will get cancelled. So what happens now? It will be 31x is equal to 8 minus 4x square. So if I convert to quadratic, it is 4x square plus 31x minus 8 is equal to 0. So finally, if you look at this, I am getting minus 32 and break it up, factorization. So 32 into 1 minus 1, right? So I am doing directly here, 4 divided by 4, so 8 is right. So this will be x plus 8 and this will be x minus 1 by 4. Okay, you can work out the way you want. So there are two values, x equals to minus 8, x equals to 1 by 4. Sometimes both the values form the value of x, sometimes only one value form the value of x. That you can always judge. Remember, 1 by 4 square is less than 2, minus 8 square is greater than 2. So I believe not less than 2. So that means 1 by 4 will be the answer. But suppose still you feel that it is not working out well, what I suggest is try to put these values in this and see whether it satisfies. So you will find x equals to 1 by 4 satisfies this particular expression, right? And remember, if you see, remember xy, right? xy should be less than 1, xy should be greater than 1 based on this formula. That's why I applied this formula, tan inverse x plus tan inverse y upon 1 minus xy, right? So finally, this answer is accepted, this answer is not accepted. So if you put minus 8, it will not satisfy at all. So x equals to 1 by 4 will be my final answer. So pause and note it down. This is the way you solve. Solving means eliminating the inverse ratio and finding the integral part, equating the integral part and finding the value of x. So I hope you got this point. The formulas are very, very important in this. Okay. One point always remember, convert both the side in the same ratio so that the integral part can be compared and basic maths comes into the picture. Okay children, so pause and note it down. Okay, look at the question here. This is tan inverse x plus 2 plus tan inverse 2 minus x equals to tan inverse, I think 2 by 3. Let me check the question here. Tan inverse 2 by 3. Great. Okay. So now the point is tan inverse x plus tan inverse y. Formula is displayed. So what I can do is tan inverse x plus tan inverse y. So tan inverse, you can say 2 plus x plus 2 minus x upon, try to understand, it is 1 minus xy. So, xy will become what? A plus b, a minus b, 4 minus x square, right, is equal to, it is tan inverse 2 by 3. Tan inverse 2 by 3, let me check it out. Yes, perfect. Now, once this is done, I have to just work out with my basic mathematics. So, this will become tan inverse 2 plus 2 is 4 upon, because plus x minus x gets eliminated, and this will be nothing but 1 minus 4 plus. So, this can write as x square minus 3 is equal to tan inverse 2 by 3. Understand what is happening, children, what is happening in this case. 1 minus 4 is minus 3. So, you can write minus 3 plus x square. I just reverse it, x square minus 3. Now, both sides you see tan inverse, don't eliminate. Okay, there is a equality between them. So, I am equating the integral part of it. So, which will generally lead it to 4 upon x square minus 3 is equal to 2 upon 3. So, you can simplify this out, that is 2 1s are 2, 2 2s are 4, and just cross multiply this. So, I think x square minus 3 is equal to 6. So, I think it will give you x square is equal to 9. So, x equals to plus or minus 3. Now, in this case, both the values will satisfy this particular thing, right. So, x equals to plus or minus 3 will be the solution. I do not think so any problem should be there in identifying. Please remember, if two values comes up, rarely it comes, but if it comes, you have to understand which satisfies, which does not satisfy. That is the important thing. Just take this and put it in this, that is it. Okay. Now, check yourself and pause and note it down. Okay, sum number 3 I just broken into two subparts. I had copied the sum again so that I understand and make the marking here and make you understand what we do with these sums. There are many ways to do this sum. You can make it compatible, sine of sine inverse and work out. There is no problem. But that might be a little bit confusing for you all, which we did in the beginning. Remember, making it compatible. So, I made it compatible, but in the end you have to find the value of x. Keep that in mind. There are other ways of doing this. So, that way I will focus on this. So, one sum I just broken out into two parts into it. So, let us see how we do this. In the end, solve. Solve means finding the value of x. Now, I will show you a very easy method of doing this. Now, try to understand this. Now, if you look at this, it is cos inverse. So, what I can do is this cos inverse I can shift this side. So, what will happen? Let us see. This will be sine of cos inverse x is equal to cos of pi by 3. Simple, easy way I am telling, instead of making the compatible format which we taught you. For solving, you can adopt this method. Now, cos pi by 3, cos 60. What is cos 60, children? Can you tell me? Because pi by 3 is 180 upon 3 is cos 60. So, cos 60 is what? 1 by 2, right? So, cos 60 1 by 2. So, this will become sine of cos inverse x is equal to 1 by 2. Now, what I am going to do? I will take this sine this side. Simple way of doing this, okay. So, cos inverse x is equal to sine inverse 1 by 2. Whose value of sine is 1 by 2? Pi by 2. So, it will be cos inverse x equals to pi by 2. Sorry, sine inverse half, it is pi by 6, right. It is sine inverse half, it is pi by 6. That is 30 degree, because sine 30 is half. So, sine inverse half is pi by 6. So, x will be what? Take this cos this side now. So, it become cos pi by 6. So, without making compatible, without any formula, you are disintegrating this and getting the value. So, finally, what is cos pi by 6? Cos 30 is nothing but root 3 upon 2. So, simple sum, okay, but a way of doing it is really trustworthy rule. Let us take the same type here, B part. I can shift this sign this side. So, what happens over here? Okay. So, this become 2 tan inverse x equals to sine inverse 1. Sine goes this side. By the way, what is sine inverse 1? Sine what value of sine gives you 1? Pi by 2, sine 90 is 1. So, you can say 2 tan inverse x is nothing but sine inverse, try to understand, 2 tan inverse x equal to sine inverse 1. So, this is nothing but pi by 2. So, as I want x value, first I will shift this to this side now, go down. So, this will become tan inverse x equals to pi by 4. Check yourself. By the way, so x will be what? Take this tan this side now, that is tan pi by 4. And what is tan pi by 4? 1. So, x is equals to 1. So, understand what we are doing. In both the cases, this is an easier way to evaluate solving a sums of these natures. Okay. So, please pause and note it down, children. It's easy part, you can carry on and absorb it very nicely. Sum number 4, have a look at it. It is sine inverse x plus sine inverse 1 minus x is equal to cos inverse x. Okay, one second, let me just confirm this question. Is sine inverse x plus sine inverse 1 minus x equal to cos inverse x. So, just write this question here once again for you. Sine inverse x plus sine inverse 1 minus x, what is it? Cos inverse x. Now, in this case, it is difficult to do the compatibility part. But this is a very little bit different sum than whatever we had done. See, you can go ahead with applying the formula that sine inverse x plus sine inverse y. So, sine inverse x plus sine inverse y, or you can convert into tan inverse, equate it up by applying the formula tan inverse x plus tan inverse y. Many ways you can do this sum. Or you can apply the sine inverse x plus sine inverse y formula also, because sine inverse x plus sine inverse x root 1 minus x square plus y root 1 minus x square. So, you know what is the problem with this question? If you go by that method, it will be very, very laborious. So, sometimes, you know, when they say solve, there is some smarter way hidden into it. Now, you might say, what is that smarter way? God only knows. Okay. So, I will just work out with this question the way I want. Okay. Now, how I do, let us see this part. Very nice question. Now, I want to remember the formula. What is cos inverse x? I mean to say, what is sine inverse x plus cos inverse x? You can remember this formula. Sine inverse x plus cos inverse x is nothing but pi by 2. If you remember that formula, what I told, in place of cos inverse x, I can apply this formula. Why? To make it simplify. That's it. That's the idea. So, let us see what happens. Look. So, sine inverse x plus sine inverse 1 minus x is equal to cos inverse x I can write as pi by 2 minus sine inverse x. Now, why I am doing this, you will immediately come to know. Or you can convert, you can apply the formula sine inverse x plus sine inverse y. No problem at all. But it will be a little bit laborious, little bit time consuming. Because sine inverse x becomes like terms. So, if I take the sine inverse x this side, this will become sine inverse 1 minus x is equal to pi by 2 minus 2 sine inverse x. Now, here the catch is, a very nice board question this is. Okay. Can I take this sine this side? Of course, I can take the sine this side. So, what happens over here? 1 minus x is equal to sine of pi by 2 minus 2 sine inverse x. So, sine 90 minus theta is nothing but cos theta. So, this will be cos of 2 sine inverse x. Now, try to understand. The problem here I got stuck, because if you look at this pattern, it is cos of 2 sine inverse x. Now, if this 2 would have not been there, then what happened? Cos of sine, you can convert it that sine into cos, and cos could have been made compatible. But this 2 is a problematic case in this case. 2 is a problematic case. Now, I will just write it down for your understanding. See, look at this 1 minus x, okay, and it is finally, I think it is cos of 2 sine inverse x. Okay. Now, as I want the value of x, I know sine inverse of sine theta becomes compatible. So now I am going to do something different approach. Okay, this is a very nice approach. Suppose if I put x as sine theta. Okay, this is the value I want. So what will happen here? Just tell me, children. This will be 1 minus sine theta is equal to cos of 2 sine inverse of sine theta. You know why I did that? Just to make it compatible. Now sine inverse of sine theta is 2 theta. So just understand what has happened. 1 minus sine theta will be cos 2. Now sine inverse of sine theta is, your game is over. Cos 2 theta. Now here there is sine theta, right? Can I change this cos 2 theta into sine? Yes. If you remember the formula, cos 2 theta is nothing but 1 minus 2 sine square theta. Do you remember this? Right? Why? So that the sine theta will become compatible in this case. So this I can write now, which is equal to cos 2 theta is 1 minus 2 sine square theta. So finally, what is going to happen? 1 minus sine theta is equal to 1 minus 2 sine square theta. So I'll just write it down here. 1 minus sine theta is equal to, bring this down, 1 minus 2 sine square theta. Check yourself. So what is going to happen now? 1 will get eliminated. I just write it down here. So 2 sine square theta minus sine theta is equal to 0. Now can I take sine theta common? I bring it here. So if I take sine theta common, this will be 2 sine theta minus 1 equal to 0. So sine theta is 0 or sine theta is 1 by 2. But what is sine theta? Sine theta is x. So from here x is 0 or x is 1 by 2. Nice question this is. I just put a star because the catch is I followed this method, because if you are going to go with a sine inverse x plus sine inverse y, it is really going to trouble you a lot. So finally this is the answer. So what is the turning point here? The turning point is here, this. Because this x, I put sine theta, because sine inverse of sine theta will get, the 2 is a problem. If 2 would not have been the problem here, I could have just used a right angle triangle and convert it into cos inverse. So cos of cos inverse becomes compatible. Because of that 2, I really have to go a longer way in doing this part of the sum. Okay, children. So nice sum. Carefully pen it down, understand this sum and work on it. Can you do that? Hi there, this is the 5th question, children. But there is a very speciality about this question. You look at the x, it is in the denominator. If you are going to go ahead with sine inverse x plus sine inverse y formula, it will be very much time consuming, because it will be sine inverse x root 1 minus y square 144 upon x square plus y root 1 minus 25 upon x square root of. So it will be a little bit complicated in nature as you go further in simplification. Other way, convert into tan inverse by doing the right angle triangle. That also will be a troublesome working, because you try it out, because I don't mind. So I'll just show you this, because this sum, I just put a star, because this sum is really important part. How to work out, I'll just show you. Now what I will do is, I will take the sine inverse phi by x that side, because it is 90 minus theta, because remember any inverse angle ratio is an angle. So this is my theta. So just to make my work easier, I am doing that. So sine inverse 12 by x is equal to pi by 2 minus of sine inverse phi by x. Try to understand what I did. Why I did that? So that I can take the sine inverse that side. So it will be 12 by x, by shifting this sine inverse on the other side. What will happen? It will become, sine inverse will become sine pi by 2 minus sine inverse phi by x. Now remember, this is my theta, so sine of 90 minus theta. So sine of 90 minus theta will become cos theta. So 12 by x equal to sine 90 minus theta is cos theta. Now this is my theta, cos of sine inverse 5 by x. Now there is no issue. Why? Because now I can use a right angle triangle and try to make it compatible. How? Everybody knows. Put sine inverse x. We can put, let sine inverse x be sine inverse 5 by x, 5 by x be theta. So sine theta will be 5 by x. So if I draw a right angle triangle, this is theta, so sine is opposite upon hypotenuse. So missing side will become, why I am doing this? Because I want to change this sine inverse into cos, that is the reason. So right angle triangle, this will be square root of x square minus 25. So now understand, I want in terms of cos. So cos theta will be what? Adjacent upon hypotenuse, root of x square minus 25 upon x. And finally, remember, theta will be what? Cos inverse. Please, you can write it on here. So theta in this case will be, look at this, I am taking it up over here, it will be cos inverse square root of x square minus 25 upon x. Now what is this? This is nothing but theta only, na? Look. So instead of writing theta as sine inverse, I will write theta as cos inverse, because that it becomes compatible. So this I can just replace. So 12 upon x is equal to cos of, this will become cos inverse root of x square minus 25 upon x. Check yourself. Now cos of cos inverse becomes compatible. So this will be 12 upon x is equal to cos of cos inverse goes off. So this is nothing but square root of x square minus 25 upon x. This gets cancelled. So if I square both the sides, this will become x square is equal to 144, that is 169. So x is nothing but plus or minus 13. So that's the way you solve this out. Carefully observe these sums, students. They are very, very exclusive sums. This has come in the board exam. It was really, students went with a normal method. They were really spellbound when they went into the basic calculation, because it was very tough to break the sum into. Okay. So this is a better way and an easier way to deal with this question. So pause and note it down. Hi. So you can see the next question, children, here. This is sine inverse x plus sine inverse y plus sine inverse z is equal to pi. Prove that x square minus y square minus z square and all that stuff. Now the question is, they are asking us to prove. See, they had given an inverse ratio and they are asking us to prove a totally algebraic format. So of course we have to use the induction method, that means from the known thing to the given thing. So let me just press down on what is given to us over here. They had very specifically mentioned in the question sine inverse x, I am rewriting it, plus sine inverse y plus sine inverse z, I beg your pardon, it is sine inverse z, sine inverse z is given as pi. Now here they are asking us to prove x square minus y square minus z square, blah blah blah, and what stuff it is. So let us see what you go. Now the question is, you can definitely, because sine inverse x plus sine inverse, you do have some root options into it. So there is no way that you convert into tan inverse and then go for that kill. But in the proof, to prove that, if you see carefully, they are not mentioned anything about inverse ratios. So let us just focus, and what I would try to do is, I'll just take this sine inverse at that side, because it is already given to you. You need not prove this part. So you can simplify this, taking both at the same time, so it becomes simpler for us. So let us see what happens. So first I'll just pair this part here. So sine inverse x plus sine inverse y is equal to pi minus sine inverse z. I think I am very clear. Now I have only one option left with me, that I can just work out with the formulas over here. So this will be sine inverse x plus sine inverse y. I can write here sine inverse x root of 1 minus y square plus y root of 1 minus x square is equal to pi minus sine inverse z. Now you might have sir, what next? Now this is the idea, look at the idea. Now if I take the sine inverse that side, so 180 minus theta, it is sine theta only. So immediately that sine inverse will go and this will completely collapse down into complete algebraic function. So let us do that. I will take the sine inverse this side. I will take the sine inverse that side. So let us see what happens. So this will become x plus y root of 1 minus x square. See what is happening, is equal to, the sine inverse goes this side, this will be sine of pi minus sine inverse z. What you see now, if you see the right hand side, sine of 180 minus theta. So 180 minus theta is what? Second quadrant, add sugar to coffee rule. So sine of 180 minus theta is sine theta. So that means it will give me x root of 1 minus y square plus y root of 1 minus x square. Sine 180 minus theta is sine theta. It is sine of sine inverse z. Sine of sine inverse z. Sine gets nullified. Right? So this part goes off and finally what is left out? It is z. Now see the objective. Look at the proof. To prove x square minus y square minus z square, all algebraic functions. Now here if this goes off z, so this is algebraic, this is algebraic, this is algebraic. So my job is done. So now I have to just look at the basic part of it and see what I can work out. So let me read the proof part. X square minus y square minus z square plus 2yz root of 1 minus x square. So root of 1 minus x square is there, right? Root of 1 minus x square. So what I would do is, I will take the square both the sides, you can do that, not a problem. But as I want root of 1 minus x square in this as it is part over here, so what I would suggest is, I will just write this out properly. X root of 1 minus y square plus y root 1 minus x square is equal to z. Now as I want 2 yz root of 1 minus x square, I will take this 1 minus x square this side. X root 1 minus y square is equal to z minus y root of 1 minus x square. Now what I can do? I can square both the sides. Why? Because if you see carefully, there is no root except of root of 1 minus x square. So I will just eliminate this root. Now let us see what happens. This is finally x square 1 minus y square. This is a minus b whole square. So a minus b whole square is a square plus b square minus 2 into a into b. This is what exactly I am getting it. So now there is a very simple way of working. Open up, that is the only cause. So just see what happens. If I open up, this will be x square minus x square y square is equal to, bring that z square down, plus bring that y square into, open the bracket, y square minus y square x square minus something is missing there. Remember this, there is an equality here. My y square is minus 2yz root of 1 minus x square. This remains as it is. Now what happens? Minus x square y square minus x square y square gets cancelled. Now see what left out. You will be surprised. Y square z square, you get everything, take this side, everything. So what happens finally? This will be x square minus y square, get the z square this side, minus z square plus 2yz root of 1 minus x square is equal to 0. Check it. Check this sum out. You had proved this particular part. Understand what is doing. They had given this question here, sine inverse x plus sine inverse y plus sine inverse equal to pi, and they are asking us to prove an algebraic. You see, there is no trigonometric at all. So I just worked out with the basic mathematics. I just took one of the sine inverse that side, I built up the standard formulas, and then I found that even though it gets converted to algebraic as it is in this case, there is no root as such in the proof. So what I did, as I want root of 1 minus x square, I shifted this root of 1 minus x square that side as I had done in this step and squared both the sides. Now what you see into it? You had seen that once we do that, then the simplification comes to your rescue. Open up carefully, steadily, you will definitely reach the final destination 1. I hope you got this message clear, children. It's a really nice sum. This has come in the board exam, so pause and note it down. Children, as you can see the sum once again, it is solving of tan of, I'll just read it out, tan inverse of x minus 1 plus tan inverse x plus tan inverse of x plus 1 is equal to tan inverse 3x. Now once again they have told us solve. So I just write the question carefully so that I just make you understand properly. So it is given tan inverse x plus 1 plus tan inverse x plus tan inverse x minus 1 is equal to tan inverse 3x. So solve. So when I say solve, remember I told you all before also, solve implies that you need to evaluate and find the value of x. But here there are plenty of inverse ratios are given to you. So what I will do, I can pair up the way which I like. I would suggest, if you see this is x plus 1, x minus 1, you can try it out pairing these two things. Okay, and then you can apply tan inverse x plus tan inverse y formula, and this you can shift that side. So both the things will fall down simultaneously. Not necessary, but it becomes a little bit easier for us to do it. So let us see this part now. So I am just merging it out. So this will become tan inverse x plus 1 plus tan inverse x minus 1 is equal to tan inverse 3x minus tan inverse x. Let me confirm the question. Okay. So it is tan inverse x plus 1, tan inverse x minus 1, tan inverse x and tan. Get it. Okay, now what happens now? We all know we use the formula of tan inverse a plus tan inverse b. Now if you look at this, tan inverse a plus tan inverse b, tan inverse a minus tan inverse b. So let us see what happens in this case. So tan inverse a plus tan inverse b. So tan inverse x plus tan inverse y, everybody knows what is the formula. It is tan inverse x plus y upon 1 minus x square minus 1, that is xy. So what is my xy here? X plus 1 and x minus 1, and you find the product of it, it is x square minus 1 is equal to, try to understand this, tan inverse x minus tan inverse y. So this is tan inverse 3x minus x upon 1 plus 3x square. So basically what is the idea behind doing this is, if you see both of them have got converted to tan inverse, right, and you can just equate the integral part because there is a equality in this case. So anyway, right now I have to do some simplification here. This will get cancelled, this will get cancelled, and what happens, let me just work out. Tan inverse 2x upon, now 1 plus 2, there is 2 minus x square is equal to tan inverse 2x upon 1 plus 3x square. So equating the integral part, now you can eliminate this 2x. Okay, you can just do this part clearly. So 2x upon 2 minus x square is equal to 2x upon 1 plus 3x square. So what you can do is, now what I am going to do is I am just eliminate this part completely. So and cross multiply, and that's the working is done. So what will happen now, this will become 3x square plus 1 is equal to 2 minus x square, 4x square is equal to 1. So x square is equal to 1 by 4. So x is nothing but plus or minus 1 by 2. So this is the way you deal with the sum. So I hope you got this point clear. It's slightly different, but definitely solving part, you need to have the value of x at its right place. So pause and note it down, children. Hi there, children. Now you can look at this next question. This is very close to my heart. This has appeared, I think, in 2016, I think so, in the board exam. And it is given sine inverse x plus tan inverse x equals to pi by 2. Fine, I am not worried with that question. But that proving part, they had given a very, very different narrative there. They had given us 2x square plus 1 is equal to 5. What is the connection between these two? Absolutely nothing. Then how I do about it? So let me write the question and make you understand. The question is sine inverse x plus tan inverse x is equal to pi by 2. It is given to you in this clear cut case. Okay, now I want everyone to pay attention now, because there are some workings which are required. So I'll just place it up over this side and work it on. So let us see the beginning. The question is whether I should convert into sine inverse or whether I convert this into tan inverse by doing the right angle triangle concept and then apply the formula. But I don't have to prove it is equal to pi by 2. I have to get into its algebraic format, because they are asking to prove that 2x square plus 1 is equal to root of 5. Is equal to 5. Root of 5, I think so. Root of 5, yeah. So let us see this part, how we go about it. Now, listen very carefully. The main idea should be simplify the function. Now, you convert right angle triangle instead of doing all that stuff. You see something on the right hand side, there is pi by 2. So pi by 2 is sine inverse x plus cos inverse x is pi by 2. So sine inverse x and sine inverse x can get cancelled at all. You getting my point? So what will happen? Just see, pi by 2 can be written as sine inverse x plus cos inverse x. Sine inverse x can get out. That means your functions become simpler. So let us see that part, what happens, and after that we will see how to go further. So what I am going to do is, I am going to keep this side as it is. Pi by 2 I can write as sine inverse x plus cos inverse x. So what happens now? This will get eliminated. Now, the problem is with this part, tan inverse x is equal to cos inverse x. As I want to convert to algebraic format, my best suggestion would be either you convert this into cos inverse or this into tan inverse by doing the right angle triangle concept. So what I am going to do is, I am going to put this as upon 1, and I can see whether I can convert into cos inverse x. Of course I can convert. Now how I do that, I'll just show it to you. This is a right angle triangle, right? This is tan. I told you tan, forget about the inverse part, it is tan ratio. So tan ratio is nothing but, can you tell me what is tan ratio? Tan is opposite upon adjacent. So opposite upon adjacent. So this will finally give me, this is x square plus 1 by Pythagoras theorem. Now I want to convert into cos inverse, so you can directly push yourself. Right? Actually the procedures you know, here there is no need to show that. So cos inverse. Now remember, cos inverse is adjacent upon opposite, so this I can write directly 1 upon root of x square plus 1 is equal to cos inverse x. You might ask me, so why you are doing, it is cos inverse, why are you doing cos of opposite upon adjacent? It is not cos of, it is inverse of this thing. So this is the input in this case, right? So don't worry about that cos inverse or cos, the end result has to come same. So both are cos inverse, so equate the integral part of it now. Now what happens, let me see. This is 1 upon root of x square plus 1 is equal to x. Square both the sides. So what will happen finally, I am just going to work out over here. So if I square both the sides, this will be 1 upon x square plus 1 is equal to x raised to square. Okay, fine. Now there is a problem in this question. Now what is the problem in this question? If you see carefully here, if I cross multiply, what happens? Let us see. It implies x raised to 4, right, plus x square minus 1 is equal to 0. What happens? Check this. It is the 4th degree polynomial and they are asking us to prove, I think it is asking us to prove 2x square plus 1 is equal to root 5. There is no trace. Fine, I just push my equation this side and try to evolve this part carefully. It is given x raised to 4 plus x square minus 1 equal to 0. Somebody has taught me when it is 4th degree, I can use the substitution, convert into quadratic so that I can factorize this part clearly. So suppose if I say let x square be equals to t. So this equation, what it will become? It will become t square plus t minus 1 equal to 0. Check yourself. Now don't you think this is the quadratic part? So quadratic everybody knows, t will be is equal to plus or minus, no, t is equal to minus b plus or minus, right, minus b is minus 1 plus or minus square root of b square minus 4 into a into c, that is plus 4 upon 2a. Check it out. So what will happen? So I am not ignoring the negative sign here. So this is nothing but 2t is equal to minus 1, see, plus root 5, that's it. Now what is the point which I tell you? Now when as soon as I see the proof, it is given prove that it is equal to root 5. Root 5 is this. I just consider negative because this both the values are true, right? But the thing is, in this case, they are asking us to prove the positive part of it. Finish. So if what is t I took, look at this, t is equal to x square, replace. So 2x square minus 1 goes this side, root 5. Don't you think you had proved what we are supposed to? I do understand you might ask me a question, so why you are ignoring the negative? I am not ignoring it. I am just considering the positive and proving that part what they are asking us to prove. I hope you got this message clear, because this is the way you have to deal with this question. This is a very nice question, and it was even I also, when I saw the sum first time, it made me think that this sum is something different than whatever the previous sums on inverse trigonometric functions has been pipelined into. So children, pause and note it down carefully, take it out, because this is one of the very rare species. We don't find these type of sums everyday life. Take it down please children.